Alright, in this video we're going to answer a couple of other questions from the volume worksheet for advanced science. These were questions that were asked about specifically through Edmodo. The first question is number 15. We're asked to find the volume of this figure, and it looks at first like it's just a box, which seems kind of straightforward, but if you look carefully you'll notice that there's a pyramid shape which has been cut out of the box. So you can see a pyramid from the top, which is being cut out down to the red dot at the bottom. So basically a simple plan of attack for this would be to suggest that after we cut out that pyramid, the volume of the remaining figure would be, grab the wrong writing instrument. The volume of the remaining figure would be the volume of the box that we see, minus, because we cut it out, the volume of that pyramid that we see there. Okay? So I've got to find the volume of the box and then subtract the pyramid which has been cut out of it. So the box is just length times width times height, and the pyramid would be the area of the base, which is length times width, and then times the height again, and then divide by 3. Pyramids and cones we divide by 3 when we're done. So essentially then you could either at this point plug your numbers in and find the answer, or if you want to be a little clever you might say, well, if we have length times width times height and we subtract length times width times height divided by a 3, then really we're subtracting 1/3 of the volume. So you could argue what's left is 2/3 of the volume, and you might just say that this equals 2/3 of the length times width times height, right? Now, if you don't want to do that, then just go ahead and put your numbers into this formula. So length times width times height for the box would be 25 times 12 times 15. And then for the pyramid, its base is the same base as the box, so 25 times 12, and its height is the same as the box, 15, divide by 3, okay, equals, and then get your answer in cubic feet. Now the answer there will have more than 2 digits, so we'll have to round it off. 25 times 12 times 15. So I get an answer of 3,000 cubic feet when I do the subtraction. So 3,000 cubic feet. To show only 2 significant digits, let's write it in scientific notation. 3.0 times 10 to the power of 3 cubic feet. Alright, let's take a look at another problem this problem was asked about as well. This is number 20 from the worksheet. We see a water tank that is 50 centimeters long, 34 centimeters wide, and 24 centimeters high, but it contains water to a depth right now of just 18 centimeters, so it's not full. We've got 4 identical spheres placed in the tank, and they're fully submerged. The water level rises by 4.5 centimeters. So if it was 18 centimeters deep before we added them, now the water level is going to be 22.5 centimeters if you want to think of it that way. It rose by 4.5 centimeters. Calculate the radius of the spheres. There's more than one way to do this. Here's perhaps a bit of a faster approach. We know that these spheres are causing the level to go up because of water displacement, right? So the volume of water displaced will equal the volume of the 4 spheres. The volume of water displaced equals the volume of the 4 spheres. Okay, now, how much water got displaced? Well, we know the length and the width are 50 by 34, and we know that the level rose by 4.5 centimeters. So we could say length times width times height, which will be 50 times 34, and then the amount the water rose, 4.5 centimeters equals, grabbing a calculator, 50 times 34 times 4.5, 7,650 cubic centimeters. Now, that's the volume of the 4 spheres. These 4 spheres are identical, we were told. So if we want to find the volume of one sphere, we'll just take that answer and divide by 4. 7,650 divided by 4 gives me, let's see, 7,650 divided by 4, 1,912.5. I'll just say 1,913 cubic centimeters. Now I'm going to worry about significant digits if you're wondering at the very end of the problem. So that's the volume of one sphere. Now the question was, what's the radius of the sphere? Now let me just go to a fresh page here. So we have the volume of a sphere, which is 1,913 cubic centimeters, and the formula for volume of a sphere is 4 over 3 times pi times radius cubed. Right? That's our volume formula for a sphere. So what we have to do now is a little bit of algebra. We've got to rearrange this equation to get the radius. Well, right now it doesn't really have just a radius, it has radius cubed. So why don't I solve for that first? Let's get the radius cubed by itself. To do that, we'll have to get rid of the 3, we'll have to get rid of the 4, and we'll have to get rid of the pi. Since the 3 is dividing on the right, we can move it to the other side by multiplying by 3. So 3 times 1,913. The 4 and the pi are multiplying the r cubed, so we can move them to the other side by dividing. So divide by 4 pi. What's left will be the r cubed. Okay, so make sure you understand that algebra. There was a divided by 3 on the right, so to get rid of that, I multiplied by 3 on the left. There's 4 pi times the r cubed on the right, so to get rid of the 4 pi, I divided by 4 pi. What's left on the right is now just r cubed. So let's grab a calculator and evaluate this. So 3 times 1,913, and then divided by 4, and divided also by pi. If you want to, another way to do it would be to evaluate what 4 times pi is and then divide by that. So I get 457 cubic centimeters. 456.9 something is what my calculator says. So that's 457 cubic centimeters is r cubed. Now we have to undo an r cubed. If it was r squared, we would square root. If it's r cubed, we're going to cube root. So we'll say r, and the way we write a cube root is a little 3, and then the root symbol, 457. Okay, now you should have a button on your calculator for cube rooting, or you might have a button that says something like this, which means take the xth root of a number. So if you have a button like this, on your calculator you're going to type a 3, that's your little x, then you press that button, and then you'll type 457. So that's the order in which you would type on your calculator. So first the 3, then this button, and then 457, and then equals. You know, if you have a button that says cube root, you could use that as well. Another way to do a cube root, this is a little different, I can explain this better in class perhaps. To take a square root is the same as to raise a number to the power of 0.5, 1/2. To take a cube root is to raise the number to the power of 1/3, or 0.33333 repeating. To take a fourth root would be to raise a number to the power of 1/4, or to raise it to the power of 0.25. So if you understand that, then you could say a cube root of 457 is the same as 457, and then press your little button for raising to the power of, Usually it's a little hat symbol like this, and then raise it to the power of 1/3, or 0.3333, repeating. Use about 4 or 5 threes. That'll get you the same answer. So let's evaluate this. We want to cube root 457. So 457, I'm going to raise it to the power of, and then 0.33333, 1/3. I get 7.70, and now the original question had 2 significant digits in the numbers, so I'm just going to call this 7.7 centimeters is the radius. If you want to double check that, just take 7.7 times 7.7 times 7.7. You should get an answer pretty close to 457, because 7.7 is the cube root of that number. All right, so I hope that helps. 2 problems from the volume worksheet that weren't solved in the previous video instructions.